So let's go ahead and do exercise 5, which has graphs that are really, really, really small on the handout. So I tried to bring the camera in, zoom in super close, so it's a little bit easier for me to see on the screen than on my paper handout. My fingers are going to appear enormous, I think. And all right, let's go ahead and do these. These, I think, shouldn't be too much trouble right now. And A, we know we have absolute value function. And when I look at the shift here, it looks like we're shifting 3 units to the right. And I think that's the only transformation that's involved. So my function is going to be an absolute value function where I need to know to write x minus 3 inside the absolute value bars, right? So there's my answer for A, just that one shift. Let's look at, so A is f of x equals the absolute value of x minus 3. Okay, let's look at B. And that looks like a shift of y equals x squared, right? And I see two things going on here. I see a shift of 2 units to the left. Shift 2 units to the left. So we're going that way. And we have to reflect through the x-axis. So those two operations, so let's see, f of x, it's going to be based on the x squared function, but inside parentheses, I have to have my horizontal shift. 2 units to the left is going to be x plus 2 squared, so that's inside the squaring. And then the reflection through the x-axis means I put a minus sign in front of parentheses. There we go. I think we got that one. Get a little off the screen. There's our second answer. Okay, third part C, absolute value. I see two operations going on. I see, now I see this as two operations, so maybe I should slow down. It's an upside down absolute value graph. So if I just reflect through the x-axis, that's absolute value, then I'm going to have a point down here where the upside down absolute value where the point is right at 0, 0. So then I want a vertical shift up 2 units after that. So let's see how we can describe this. We're going to take absolute value where we want to shift, we want to reflect through the x-axis. So that's minus absolute value of x. And then I want to shift up 2 units. And it's going to look like so. So I add the plus 2 outside the absolute value bars because this is a vertical shift, right? Now, you can also write that answer, same answer, in the following way if you want to show off a little bit. Write that 2 minus the absolute value of x. I consider that the confusing way to write that because that's equivalent. We just rearrange the terms, but it's a little bit easier to see the transformation in the first form. So there's C. Okay. Let's go ahead and do D. Okay, D, we're back to x squared graph, right? And it looks like we shift two ways, right? We're going to shift to the right by 2, and we're going to shift down 1, 2, 3 units, right? So we have both a horizontal and a vertical shift for this transformation, no reflection. We're going to start at 0, 0, go to the right, and then down. So this is going to be f of x equals, we're going to have inside parentheses our horizontal shift. To the right 2 is minus, x minus 2 squared. And then down 3 is outside the parentheses, a minus 3. I guess I didn't need to leave a space there. So there's my formula for D. Okay, E. Okay, looks like square root. Oof, I hate the square root ones. Okay, it's square root. And it looks like I did a reflect through the y-axis. And, you know, again, that initial point always seems to start at 0, 0. So it looks like I've also done a shift up of 2 units. So let's see how we're going to express that. We're working with the square root function to shift through the y-axis. Now this is that funny looking one. Didn't we do one example of this strange looking thing where we take the square root and inside of it we change x to minus x? And then we're going to shift up 2 units, so make sure you close your backdoor, your square root, and we're plus 2. That's funny looking. But see, that's a function you can plug in negative numbers, negative values of x into, and get something that makes sense. And this is a function that's defined for negative values of x. So square root, okay, with 2. And one more, f. So let's see, part f here, we got square root again. Ugh. And this time it looks like I reflected through the x-axis. And no vertical shift, but it looks like I have a horizontal shift. A shift of 1, 2, 3. Shift 3 to the left. That away. Alright, so let's see. So we're dealing with a square root function. The horizontal shift has to go inside the square root, and it's got to be x plus 3 because I'm going to the left, so it's the counterintuitive one, right? Because I'm going to the left, so I write plus. And reflect through the x-axis means I put the minus sign in front of the function expression, in front of the square root. And I think that's got it for me. That's got my 2 transformations. So it's pretty cool that we can write these down, these fairly complicated formulas, just by staring at the graphs. And that's pretty much the end of our class lecture work on transformations.